you, my friends? This is lecture 32 of the algebra course. This is a continuation of lecture 31, transformations of functions. And this is about stretching and shrinking. We will also mention even and odd functions. Just to remind you, please, that in the transformation, we had the shifting and the reflecting graphs in lecture 31. And we have stretching, shrinking, and even and odd functions in lecture 32, which we are taking now. Now, stretching, we have a vertical, stretching and shrinking. We have horizontal. I will start with example just to show you the idea. If you have a graph like this is the black one, see, just a graph, f of x. If I multiply the whole function by 2, see, g now is 2 times f of x. See, the whole function here is multiplied by 2. So this is the red. So the maximum here in the 3 is 4, so it becomes in the 8. See, we stretch it. So we call this stretching, vertical stretching by a factor. C is the factor here. We call it a factor of C is equal to 2. K of x, now 0.5 times f. This is f is the black. If you multiply by a number less than 1, 0.5, see, it will be vertical shrinking. So it will be like lower. Stretching, it will be higher. See, from this here, 4, if you multiply it by half, it will be at 2. So this is the blue one. Blue shrinking down here, and this one, the red, is the stretching, the vertical. Now we take the formula here. So if we have a point x and y in the function f, if you multiply the c by the y, that means vertical stretching or shrinking. If c is greater than 1, that's a stretching here. C between 0 and 1 is the shrinking, and we call c is the factor. So c times the y. C is the factor. Now let's graph 3 functions, f of x, r of x, b of x. This one absolute value, this is 4 times absolute value, 1 over 5 times absolute value. On the same axis, maybe, yes, on the same axis. So f of x, the original one, is the V shape, we know that. If you take a point here just as an example, put x equals 2, y will be 2. So 2, 2 on this graph, the black. Let's see, the stretching is the red, and the shrinking is the blue. So that's why I call this one R function, R of x, and then B of x. Okay, 4. So if you multiply this function, f of x, by 4, it will be vertical stretching. See the vertical stretching. So this point will go to 2 times 2, 8, because we multiplied the 2 by 4. Every y multiplied by 4. And then in the other one, the vertical shrinking, 1 over 5. See, 1 over 5 is less than 1. So that's a vertical shrinking. So the graph will be like this. So it will be the point 2, if we have the same point here, 2, 2 over 5. Because 2 times 1 over 5 is the C factor. Now, horizontal, if we have f of cx, so x is multiplied by c. If x is multiplied by c, this is a little tricky, guys. If x is multiplied by c, then the factor is 1 over c. I will explain in the coming examples why. If x is multiplied by c, so we have f of cx, then the factor will be 1 over c. We multiply 1 over c times x, or x divided by c. If c is greater than 1, shrinking. If c between 0 and 1, it is stretching horizontally. I have to show an example to understand it better. Let's take this function here. This is a graph here, and this is the function f. Graph the function small r of x, b of x. F of 0.5x, f of 3x. We need to graph these 2 functions. I will take the first one, r of x, f of 0.5. Now what is c here? This is the c, 0.5 multiplied by the x. See here, cx. You see that, cx. And the other one in the formula, C times f of x. C outside, the other one is C inside. Now let's see R of x, what will happen here. C now is 0.5. C between 0 and 1, so this is horizontal stretching. So the graph will be stretched. See, the black one is the original one. How do you know stretch? You can see x old, this is the old here. X old is equal C times x new. So x old, what is x old? Is 1, right? X old is 1 here. Let's take 1 or minus 1 also. See, minus 1 x old, 1 is x old. 1 is the x old, 0.5 times the x, because we multiplied x by 0.5. So x will be 1 over 0.5. The new x will be 2. See, that's why from 1 to 2, the graph is stretched and bigger horizontally. And minus 1 is the old. Just remember that one. X old minus 1. C, whatever the C is. Now in the next example, it will be C3. This one 0.5. It can be 7 or 2. 0.5x. So x will be minus 1 over 0.5. It will be x new minus 2. See, from minus 1 goes to minus 2. So the black is the original graph. If you multiply x by 0.5, x, if remember, every x, the graph becomes horizontal stretching. See, xy in f. Remember, this is the black, xy in f. C is 0.5, so x over 0.5. Because the formula here, the factor is 1 over c. So if you multiply x by c, you divide x over c, and y will stay the same here. If you have a number outside, you multiply the y by the factor outside. Now let's see the second one. The second one is this. See, C 3 now. C is 3, greater than 1. Still x old is equal C times x new. X old is 1. 3 is the C. We need the x new. X new 1 over 3. See, from 1 to 1 over 3. So this is horizontal shrinking. So it is smaller. Smaller with bigger C. If the C is multiplied by x horizontally. Shrinking horizontally. Same thing from minus 1, it will go to minus 1/3. That's the blue graph. Now, in this slide here, I will show why we divide from where we get x old is equal to C times x new. I will show you now here. Suppose we have a function, normal function, parabola, f of x is equal x squared minus 9. Now, the x-intercept of this function is easy. Let y equal 0, so it will be minus 3 and 3. We know that. Now, suppose we have a new function now, g of x. A g where we have f of c of x. So every x in the function f, we multiply it by c. F of cx, just apply the function here. It will be cx squared minus 9. Let's find the x-intercept of the g. Put y equals 0 here for the g. So cx squared minus 9 equals 0. Factor it. Cx plus 3, cx minus 3. Now cx plus 3 is equal to 0, or the other one is equal to 0. So x will be, if you solve for x, minus 3 over c. And the new x will be 3 over c. You see? See the old ones here, minus 3 and 3, that's the old, and then divided by c. So you have to, if you have horizontal shrinking or stretching, f of cx, see, cx multiplied by c in the function g. So you divide by c, the old values of the x. Now, let's look here at nice example here. We have a graph like this. That's f given. See, given is the graph of the f. Sketch new graph g. And here we have three things. We have minus 3 f of 0.5x. After you finish, you find the domain and the range of the function g. So you have to graph the g, find the domain, find the range. Now you have to compare G to F. This is the function F here. What happened? There is a minus, see? There is a minus. That means there is a reflection in the x-axis. Remember reflection in the x-axis. Now, 3. Multiply the whole function, 3. So it will be vertical stretching. Vertical stretching, why? Because C3 here is greater than 1. See, this is the old graph, F. This minus given the G is the reflection. Now 3, vertical stretching, because the 3 is bigger than 1. So the whole graph stretched bigger here, wider, vertical stretching, that's the red. Now, in the horizontal, we have 0.5. Remember, 0.5 is less than 1. So less than 1, we have to use 1. This is the 1 here, 0.5x. So x will be 2. So from 1, it will go to 2 here. And 5, it will go to 10, because 5 is equal c times the x new. X new will be 5 over half, 10. So this is horizontal stretching. So the graph is stretched horizontally. Now the blue one here is the final graph. There are 3 changes. 1, reflection, stretching vertical, horizontal stretching. The graph of G is the final one, solid one. The domain will be on the x values close 2 to 10. The range, it will go from -12 until 0 closed. That's the range of G. Please review this one, important question. This is another important question here maybe. If f is a function such that f of -10 is equal to 9, find the coordinates of the points on the graph of function m. 1/3 f of 2x. Just try to understand it. This is the same as 11. You see 11, example 11, we have given the whole graph. You see the whole graph of f. Find the whole graph of G. Now, in this next example here, I'm giving you only a point, like 3, 4, or 4, 3, or 5, 0, or 1, 1, any point, only point on the graph. See what will happen to this point after we make the transformation. So that's example 12 here, just 1 point. So f is a function, f of -10 is equal to 9. So x is -10 and y is 9. So there is a point -10 and 9. You can graph it. We need the point that lies on this function m, which is 1/3 f of 2x. See, that's f here. So the whole function multiplied by 1/3, which is the factor here, 1/3. And this is the factor c inside is 2, bigger than 1. See what will happen here. From the function here, I take this point, -10, 9. That's the point here. You draw it. See, that's a black. Easy and nice in quadrant 2. 1/3, see 1/3 outside. So this is the factor, let's call it B. 1/3 means vertical shrinking. Why shrinking? Because this number here, 1/3, less than 1. And this number outside. So you multiply it by y. See, the -10 stays the same. The y will be multiplied by 1/3. So 9 times 1/3 become, this is vertical shrinking. See, the same what we applied in example 11 will be in example 12. Example 11, the whole graph. Example 12, 1 point only. So that's -10 and 3. Now, there is a factor for 2x here. A is equal to. This is horizontal shrinking because x will be divided by 2. So x will be divided by 2, -10 is divided by 2, becomes -5/3. -5 and 3. -5 and 3. That's the point on the function m after we make all the transformation of this point -10, 9. This is another way easy you can do. This is the given, if you want. This is the given. See a, here y, the x is divided by a. A is the factor 2. And 9 here is the y, so we multiply it by b. B is 1/3, it's outside. You can do it this way if you like, without graphing. So you go from minus 10, 9, minus 10 over A, which is minus 10 over 2, B times the 9, 1 over 3 times the 9 is 3. So that's the point now. Let's look now at example 13, where we have the graph is given and we need to find the function. Starting from f of x. So we have find the equation of the function whose graph is given. Starting from f of x is equal to absolute value and applying several transformation discussed in the lectures here, 31 and 32. So we look here, we see this is a V shape. So we know that's an absolute value, we know that. And there's a shifting here. She's shifting on the right 2 units, 1, 2, and down 1. But maybe the shrinking and stretching is not clear. So what can we do? We look at the graph, and then we try to write a function g, absolute value, same here, absolute value x. On the right, so we say x minus 2, down 1 unit, so right minus 1. And then I put c here. C will take care of the stretching and shrinking, just outside. See, from the graph here, we see the x-intercept will be 4. So we just take a point on the graph, like 4, 0. So I put here g is 0 here for the y. C, we leave it here. X is I put 4. 4 minus 2 minus 1. Simplify, take 1 on the other side. C will be half. So that's the function. So this is a vertical shrinking because the number outside is less than 1. That will be taking care of everything in the transformation. Now let's define even and odd functions. Important to know, function is even if f of minus x is equal to f of x. If the function is even, symmetric with respect to the y-axis. Function is odd if f of minus x is equal minus f of x, and if it is odd, it is symmetric about the origin. If the function is not even, not odd, the function is called neither. Now let's see some examples here. Determine whether the function even, odd, or neither. So I just take the function like a, b, we have another example. Also, I replace x by minus x. See the idea here, to replace x by minus x, and then simplify, simplify, simplify to the end until you get either the function or minus times the function, or none of these. So that's the idea. So I replace x by minus x in the original equation. This is the equation of the function. So I put f of minus x, this minus from the question there, and minus x cubed. So minus x cubed becomes minus x cubed, multiplied by itself 3 times. This becomes plus. Now, is this the same as the function f? No. So this is not even. Now we continue. Take a minus outside. See from the bracket here. Take a minus common factor. So it becomes minus. Inside we have x minus x cubed, which is the same as the function. So I can write f of minus x is equal minus f of x. That's the odd. You see the odd definition? F of minus x is equal minus f of x. This function, the given one, is odd. Let's see the second one. 10x minus 3. I replace x by minus x. So 10 times minus x becomes minus 10x minus 3. This is not equal to f directly there. Not the same as f. Not even. Take a minus out. Even, this is not minus f of x, not odd. Not even, not odd, the function is neither. Now, a little more difficult question. Determine whether this function is even, odd, or neither. We have f of x, x times absolute value of x over cube root of the x. As we have mentioned before, let's take the function and replace x by minus x in the original equation. So f of minus x is equal to minus x, absolute value of minus x, cube root of minus x. Absolute value of minus x is the same as absolute value of x. We have seen in Algebra Course Lecture 4. You can see that, please. And then cube root of minus x, we can take the minus out. This is lecture number 7. See, this minus will be cancelled. So again, we have x times absolute value of x over cube root of x, which is the same as the function f. So if f of minus x is equal f of x, that means the function is even function. Now, I have prepared for you some old exams questions related to transformation of functions in the shifting, in the reflection, in the stretching and shrinking, even and odd. General questions. Please try all these. The first one, there is a reflection and you have to try it, please. And then try the next one is very nice, not easy. I'm very sorry for this. This graph y squared minus 6y is equal x squared minus 9 divided by 5x plus 15 shifted 3 units down and 3 units to the right. Find the equation of the new transformed graph. You can do it. Not that easy. This one, given a function f, you need a function g. After we do all these transformation, you have to read it and check it, please. Number 4, take the graph here. The function is very nice. Square root, graph it, find x-intercept, y-intercept, domain, and range. This one you have to describe, like write. Describe how the graph of this can be obtained from the graph of this. So the idea here, start down here, y equals square root of x minus 2 plus 2. Start there. Explain in English and writing, what are the steps, the transformation, what happened to this one until we reach this one here. This is the aim, we call it the aim. Now here we have a graph, find the function as we did in the examples. Check even, odd, or neither, very similar to the one also we did there. Number 8 is the graph is given y equal f of x, and you need to sketch the function L of x, which is minus half f of x minus 1 plus 1 outside. Remember, there is a minus half outside, there is a reflection, and there is a shifting here, and there is a shifting also. Find the domain and range of the function L after you graph it. Number 9, the same idea where we have 1 point, f is a function such that f of 4 is equal to minus 6. Find the coordinates of the point on the function g, 2 minus 1 over 3 f of x minus 3. So make all these transformation to this point, the point 4 and minus 6. See what will happen to this point. And now, in the last slide, you will find the answers of these 9 questions. Only the answers, final answers, for sure with nice colors. Now, for complete solutions of these 9 questions, please, you can go to all the exams questions, transformations of functions. So 2 lectures, 31 and 32, I have prepared 9 questions all together. You can see it in one video with complete solutions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I wish I can see you in another video with another topic. Thank you very much for listening. Bye.